Hello. Now, a common situation in energy problems involves a pendulum, a wrecking ball, Tarzan swinging on a rope, something like that. And it can be challenging for someone new to this to figure out what is the change in height. So in this video, I hope to show you how to figure out that change in height so you can figure out the change in gravitational potential energy of the ball. So here we have a wrecking ball. It's a big metal or concrete ball attached to a crane that they swing to demolish buildings, knock things down. So here we got a 700 kilogram wrecking ball suspended from an 8-meter long cable. The cable's pulled back so that it makes a 20-degree angle with that vertical. So that's this angle right here. That's 20 degrees. By how much has the gravitational potential energy of the ball changed? Well, change in potential energy of gravity is potential energy of gravity final minus the potential energy gravity initial. So final is here in A, initial is here in B. So how do we find these? Well, that's going to be mg, the height at A, minus mg, the height at B. Now what I'm going to do is I'm going to make B my zero height. I'm going to make that 0. So let me draw that a little better over here. So we've got, here's the ball when it's at B. And then here is the ball when it's at A and B. Now what we want to find is if this is HB is equal to 0, I'm going to find HA. How big is that? That's this right there. So here's how we go about finding that. Right, first of all, we'll use some colors. The length of the string, which is 8 meters long, length of the cable, 8 meters long, that's this, that's 8 meters, and that's this. Those are both 8 meters. We'll make that L, right? The yellow part is L. L is yellow. We want to find this part. This is what we want to find right here. This orange. That is our change in height, or our HA. The change in that height is just going to equal HA. It's HA minus HB, but HB is 0. That's the orange thing. That's what we want to find. That's an orange. Well, we can find that orange one by subtracting this green part from the yellow part. So what is that green part? How big is that? This angle right here is our theta, which is 20. So that green part is, this is L. L is the yellow length, the length of the cable. So the green part is L cosine theta, right? And that's because cosine theta is adjacent over hypotenuse, and that is the green part over L. That's the green part over the yellow part. And we can rearrange that for the adjacent side, and we get that. L cosine theta is what that is. So that H, then, right here, that change in H, that orange part, that is the yellow part minus the green part. So change in height, which is our height A, is L minus L cosine theta. All right, and sticking with our color coding, that orange is the yellow minus the green. So that's how we can do it. So if we plug that all in, our numbers, if we come over here, this is going to be, we can factor out the mg. We got mg, ha minus hb. hb is 0, so it's equal to mgha, which is this, mg times L minus L cosine theta. We could also factor out that L, and that's mgl 1 minus cosine theta. Plugging in those numbers, we've got 700 times 9.8 times 8, 1 times 1 minus the cosine of 20. Plug those into your calculator, and we get wow, 3,309.6. 3,309.7, but we got 3 digits up there, so that's 3,310 joules. That is our change in U. Right there. So that's how you figure out the change in height during a pendulum swing, by taking that total length and subtracting that length. Remember, this position A is higher than B, so you can't measure, I mean, you could measure it down, you could measure them down, but the down heights would be negative. This is working all kinds of problems that are going to come up here in work and energy. Thank you very much for your time.